Hello friends, welcome to my channel Physics with Rakshit. In the present lecture, I will explain one of my published research article of my doctoral research work, that is low quantum gravity, a demystified view. So in this research article, the attempt is made to demystify loop quantum gravity in concise and lucid way. What is loop quantum gravity? Loop quantum gravity is the background independent and non-perturbative approach of quantum gravity theory, and it is one of the supposed candidate of theory of quantum gravity. To study loop quantum gravity, first of all, prerequisite concepts are given in this lecture. Thereafter, I will explain canonical quantum approach of low quantum gravity, that is ADM formalism, with the explanation of metric formulation. Later on, I will explain various associated concepts such as connection formulation and tetrad, spin connection, Palatini action, etc. With the modification of connection formulation, Astakal formulation is proved to be current framework of loop quantum gravity, which is very essential to explain modern frontier of loop quantum gravity. Thereafter, I will explain kinematical and dynamical framework, that is spin network and spin form of loop quantum gravity. Thereafter, I will explain quantization of geometrical observables such as area and volume. And in the end, I will describe some applications of loop quantum gravity such as black hole entropy problem and loop quantum cosmology. So here I have given link of my published research work, which is published in Springer journal, that is gravitation and cosmology. I have also given DOI number of that published research paper. So first of all, what is quantum gravity? Modern physics has two pillars, that is general relativity and quantum field theory. By merging general theory of relativity with the quantum field theory, one gets quantum theory of gravity. So here I will just give glimpses of this theory, as I have to explain all of the concept of loop quantum gravity in the present lecture. So I will just provide some definition and some introduction of each and every theory. So what is general relativity? It is the geometric interpretation of gravity based on Riemannian geometry or non-Euclidean geometry. Here, considered geometry is curved when and where matter is localized, and that is why John Wheeler once told that mass tells spacetime how to curve and spacetime tells mass how to move, while quantum field theory governs microscopic behavior of matter with the aid of quantum mechanical operators on Hilbert space. So here we are reconciling general relativity with quantum field theory, and that is why here matter is described by quantum field theory, which in turn coupled to geometry, so quantum theory of gravity is needed. In my doctoral research work and in my doctoral thesis, to study quantum gravity, I have focused on loop quantum gravity. To explain quantum gravity, any kind of quantum gravity theory, one has to consider Planck scale. And there are various fundamental Planck quantities in physics, such as Planck energy, Planck time, Planck temperature, Planck length, and Planck mass. Planck energy is of the order of 10 raised to 28 electron volt, while Planck time is of the order of 10 raised to minus 44 second. Planck temperature is of the order of 10 raised to 32 Kelvin. Planck length is of the order of 10 raised to minus 35 meter. Planck mass is of the order of 10 raised to minus 8 kilogram. So in this diagram, I have shown how one can get quantum theory of gravity by merging classical mechanics, Newtonian gravity, quantum mechanics, electromagnetism, special relativity, general theory of relativity, quantum field theory, and quantum field theory in curved spacetime. One gets quantum theory of gravity. So, first of all, before I describe loop quantum gravity in detail, in this slide, I will give some discrepancy between string theory and loop quantum gravity, and I will give reason why I have chosen loop quantum gravity over string theory. So, first point of discrepancy is string theory can unify gravity, electromagnetic, strong nuclear and weak nuclear force, and that is why it is supposed to be the theory of quantum gravity as well as theory of everything. While loop quantum gravity can unify quantum theory and general relativity, and that is why it is promising candidate of theory of quantum gravity. String theory is background dependent, while loop quantum gravity is background independent. To understand string theory, one has to study supersymmetry, and that is why here supersymmetry is required. While in case of loop quantum gravity, supersymmetry doesn't require, but it doesn't exclude possibility of supersymmetry within the framework. In string theory, it requires 11 dimensions to comprehend various concepts, while loop quantum gravity requires usual 4 dimension. String theory is originated from quantum theory, while loop quantum gravity is originated from general theory of relativity. In string theory, strings are one-dimensional object that moving in space, while in loop quantum gravity, loops are one-dimensional object that forming space, which shows that string theory is background dependent and loop quantum gravity is background independent. String theory doesn't violate Lorentz invariance, while loop quantum gravity may violate Lorentz invariance. String theory is perturbative as well as non-perturbative. Particular approach of string theory, that is anti-de Sitter conformal field theory, is non-perturbative approach, while loop quantum gravity is non-perturbative. In this diagram, I have shown generated picture of quantized space-time in loop quantum gravity. And in the first image, I have shown world line, world sheet, and world volume of particle, string, and brane respectively in string theory. So in this slide, I have shown various prerequisites to study loop quantum gravity. As I mentioned earlier, in this lecture, I have to explain various concepts in limited time. That is why I will not introduce each and every theory in the present lecture. So, conceptual background from physics, special theory of relativity, general relativity, covariant electromagnetism, Lagrangian, Hamiltonian formulation, quantum mechanics, and quantum field theory are required to study loop quantum gravity up to some extent. So first of all, you have to clear your basic regarding this whole theory. Thereafter, you can understand the present lecture. In mathematics, you will have basic knowledge of differential geometry, especially tensor analysis, functional analysis, topology, global analysis, algebraic geometry, group theory, knot theory, index theorem, non-commutative algebra, and infinite dimensional analysis. Thereafter, you can understand mathematics of loop quantum gravity. So as I mentioned, mass tells space-time how to curve, space-time tells mass how to move. This small sentence uttered by John Wheeler explain whole general theory of relativity. What happens in flat geometry, parallel transport of vector is possible, but in case of curved geometry or non-Euclidean or Riemannian geometry, parallel transport of vector isn't possible. So here in the first image, I have shown parallel transport of vectors in flat geometry, and in the second image, I have shown in curved geometry in sphere. What happens if you consider parallel transport of vector? There is a geodesic deviation introduced whenever you are studying parallel transport of vector in curved geometry. So first of all, you have to consider covariant derivative equations and mathematics of covariant derivative. Thereafter, you have to consider Christoffel symbol, Riemannian tensor, equation of Riemannian tensor, and using the Christoffel symbol, covariant derivative, equation of Riemannian tensor, Ricci tensor, Ricci scalar, you will have equation which is known as Einstein's field equation, which establishes relationship between mass and space-time or mass and curvature. In my research article, I have explained and I have derived all this equation. Interested viewers can find this derivation in my research article. So as I mentioned, string theory is background dependent while loop quantum gravity is background independent. To study background independent, one has to consider diffeomorphism invariance. It is a kind of symmetry which tells that law of physics remain invariant under differentiable coordinate transformation or under various choice of coordinate system. This symmetry is the basic outcome behind the idea of general covariance. Almost all fundamental physics theory, like quantum field theories, various quantum field theories such as quantum chromodynamics, quantum fluorodynamics, quantum electrodynamics, are invariant under passive diffeomorphism, while general relativity and loop quantum gravity involves active as well as passive view of diffeomorphism. In this diagram, I have shown active and passive diffeomorphism invariance, which involves choice of coordinates and old and new basis. So what is quantum field theory? So you are aware with the concept of mass energy equivalence, that is equal to mc square. By studying this and by combining it with the special relativity, it tells that energy can be converted into mass and vice versa, while uncertainty principle of quantum mechanics, which is delta E into delta T greater than or equal to h cut by 2, which physical significance is energy can fluctuate frequently for a shorter time. By combining the idea of special relativity with this idea of quantum field theory or quantum physics, one can say that frantically fluctuated energy can have quanta of short lifetime, which can be seen as field. It means quantum field is everywhere in our universe. So whole world is made up of such different fields relevant to different particles. In general relativity, space and time are at equal footing, which we are calling space-time continuum. In quantum physics, position is mathematical operator, while time is just parameter. In quantum field theory, wave function is considered as field, and these fields are mathematical operator, while space and time are, which is in bracket x and t, are only number or point in space. Momentum behaves as operator in quantum field theory. So wave functions which represents field are promoted as quantum operators in quantum field theory. which is known as field operator. For instance, any field psi of xt, its conjugate momentum can be represented as operator pi of yt is analogous to canonical variable in bracket qp. So here qp is promoted as squared bracket qp tends to operator psi of xt, operator pi of yt. So in squared bracket, operator psi of xt, operator pi of yt is equal to I reduced Planck constant delta of x minus y. Another important concept is Yang-Mills theory. So low quantum gravity uses Yang-Mills theory, which is one sort of quantum field theory, and it is based on special unitary 2 representation group, which is the integral part of quantum field theory of weak nuclear interaction or quantum flavor dynamics. It is a type of gauge theory which uses non-abelian Lie group to describe characteristic of elementary particle. Gauge theory is one of the crucial theory to understand modern quantum field theory. So first of all, viewers must be aware with the gauge theory and basics of gauge theory. It involves gauge transformation in which Lagrangian remains invariant under transformation. So it is the generalization of electromagnetic theory to understand strong and weak nuclear force, and it unifies them with electromagnetic force. It is important to comprehend standard model of particle physics. In 1986, Indian-born physicist Abhay Ashtekar discovered new variable of quantum gravity which provoked research in connection formulation. I will explain what is connection formulation soon. So in general relativity is written in terms of Ashtekar variable analogous to Yang-Mills theory. Maxwell's electromagnetism, which has unitary one symmetry and abelian by nature, is one of the case of Yang-Mills theory. So this is how present framework of low quantum gravity is connected with Yang-Mills theory. In usual prescription, starting from vector potential with 4 matrices, that is Pauli matrice, one gets a gauge theory which is analogous to general relativity in terms of Ashtakar's new variable, and it forms base for connection formulation of quantum gravity. So as I told, you have to clear the concept of gauge theory to understand the derivation of low quantum gravity. So to explain Ashtakar variable, first of all, I will consider gauge connection in quantum field theories. That is, d mu is equal to del mu is plus ig a mu, where a mu prime is equal to a mu minus del mu omega. Here d mu is kind of derivative similar to covariant derivative. A mu is connection. Let us consider action, that is S is equal to integration L d raised to 4 x, which will in turn gives us Dirac's famous equation, that is IH cut gamma raised to mu del mu psi is equal to mc psi. So action will become st is equal to integration d raised to 4x bar psi in bracket IH cut c gamma mu d subscript mu minus mc square bracket close into psi. So we will have final equation of gauge derivative which has connection term d mu is equal to del mu plus ig a mu j tj. By combining this equation with the standard equation of action of quantum field theory, we will have S is equal to st plus sg is equal to integration d raised to 4x in squared bracket by psi in bracket I h cut c gamma raised to mu capital D mu minus mc square psi, bracket close psi plus in bracket minus 1/4 trace of f mu nu f's superscript mu nu bracket close square bracket close. So this is the basic equation of action of quantum field theory which contains gauge connection. Let us see what is parallel transport and holonomy in quantum field theory. Thereafter I will explain the importance of holonomy in loop quantum gravity. The concept of holonomy is very crucial in loop quantum gravity. In generating loop states, holonomy defines the value difference between initial and final vector transported. In this case, when we are talking about quantum field theory, it is like spinor transported as it involves spinors instead of vectors during parallel transport operation on closed loops. Here gauge rotation is present in internal components. So rotation action is defined as small u of x is equal to e raised to in bracket I omega capital J of x t capital J bracket close. Capital U of dx superscript mu bracket close is equal to e raised to in bracket ig a mu dx mu bracket close. Here dx mu is separation in terms of displacement between different considered field point. I will explain this by considering this image. The mathematical entity capital U of dx mu is known as parallel transport operator. It is used in the comparison between two different considered field values at different position. If you are aware about parallel transport of vectors that I have explained in my channel, in my one of my lecture, you can easily understand this concept. Parallel transport of vector or spinor is dependent on path and exhibits exponential. You can clearly see by considering the equation. Using the value of connections, this parallel transport is defined for finite separations along any arbitrary curve or closed loop, that is epsilon u of xy. So equation is capital U of xy is equal to capital P e raised to in bracket integration epsilon ig a mu raised to j of x tj dx u. Here tj is the gauge group generator, capital P implies path ordered integral, very important term, and x and y are endpoint of considered arbitrary curve epsilon. Here a subscript mu superscript j is the connection and j belongs to 0, 1, 2, 3. In loop quantum gravity, holonomy is referred as path ordered exponential, which is very essential to create loop states on closed loop when spinor transport in gauge theory is considered with gauge connection. The spinor transport involves curvature of gauge theory, which is bounded on closed path, while the vector transport involves spacetime curvature, which is bound on closed path. So let us see what is Wilson loop, which is very important concept of loop quantum gravity. Wilson loop is gauge invariant quantity which is obtained from holonomy of gauge connection by considering spinor transport on closed path. Consider a big square net made from threads in which there are many small squares adjacent to each other. Just looking that image and listening whatever I am explaining, you will understand what is Wilson loop. Each small square behaves as closed path and traversed in clockwise direction. The side of two adjacent squares are traversed in opposite direction. So both sides are cancelled by each other. The only effective side is sides that are aligned to main big square. So one big closed path is obtained in terms of big square in clockwise direction, and it covers total area of squares. This closed path or loop in terms of big square traversed in clockwise direction is known as Wilson loop. Here, square shape is considered while shape may also be arbitrary in shape. So as we haven't defined whatever shape loop may have. So Wilson loop was named after Kenneth Wilson. The derived holonomy from this loop is known as Wilson loop variable. It is invariant under gauge transformation. So final equation is W epsilon is equal to trace parallel transport operator P e raised to in brackets closed integral epsilon ig a mu j of x tj dx mu bracket close. Here in this slide, I have shown some discrepancies between general theory of relativity and quantum field theory. For instance, general relativity comprehends gravitational force, while quantum field theory comprehends electromagnetic, strong nuclear, and weak nuclear force. First one is background independent, second one is background dependent. General relativity is continuous and deterministic by nature, while quantum field theory is discrete, uncertain, and probabilistic by nature. First one describes relationship between space-time and matter, while second describes relationship between gauge charge and gauge field. First follows diffeomorphism invariance, while second follows gauge invariance. Covariant derivative of general relativity is given as del A Vc is equal to del A Vc plus Vb, first of all symbol, gamma raised to C AB. Gauge covariant is represented as d mu is equal to del mu plus Ig A mu, or d mu is equal to del mu plus Ig A mu j Tj. Here gamma raised to CAB is a fine connection or Christopole symbol, while A mu or A mu J is gauge connection or spin connection, which is also known as Yang-Mills connection. General relativity involves vector and tensor field, while quantum field theory involves vector, tensor, and spinorial field. General relativity involves SO3 group, most possibly, or special orthogonal group, while quantum field theory involves U1, SU2, SU3, and SL2C group. General relativity is useful to understand macroscopic physics, that is astrophysics, cosmology, etc., while quantum field theory is useful to understand microscopic scale, which is atomic, nuclear, and particle physics. So in loop quantum gravity, there are two approaches of dynamics, that is canonical quantization, and second one is spin form. Here I will explain both approaches. Canonical quantization uses Hamiltonian mechanics with 3 plus 1 decomposition. It means 3 space dimension, 1 time dimension, which is known as ADM formalism, which leads to Dirac's procedure of canonical quantization or second quantization. While covariant approach or path integral approach, which is also known as spin form, uses Lagrangian mechanics, find transition amplitude of geometry or quantum spacetime. Similar to path integral, here one has to consider sum over geometry. Here Feynman's sum over history is replaced by sum over geometry, and probability amplitude is said to be transition amplitude. In the Hamiltonian approach of loop quantum gravity or canonical quantization, ADM formalism, which stands Arnovit, Bezer, Mishner, space and time are divided into three-dimensional hyperspaces and time. That is ordering between these hyperspace that I will explain soon. These hyperspaces plays the role of level surfaces between time parameter t. The way how this formalism generates time is a bit difficult to grasp in the first glance, though this doesn't affect actual dynamics. That is why sometimes low quantum gravity is criticized because of frozen time, but actually it doesn't like that. So in this diagram, I have shown two hyperspaces and time parameter t, schematic diagram of 3 plus 1 decomposition or ADM formalism in which sigma t and sigma t plus 1 are hypersurface. T mu is vector field, N mu is normal vector, and capital N is lapse, and N mu is shift vector. Here lapse will provide time parameter or time dimension. T mu is equal to capital N N mu plus N mu. Here metric tensor G mu nu is equal to, in bracket, first element minus n square plus n raised to c and c. Second element in first row is nc and c. First element in the second row is nc to nc, and second element in the second row is gcd. By some simple mathematics, we will have final line metric, that is ds square is equal to, in bracket, minus n of t square plus ncnc dt square plus 2nc dt dxc plus gcd dxc dxd. Thereafter, I will explain intrinsic and extrinsic curvature in metric formulation. Before I explain connection formulation and Ashtakar variable, I will explain metric formulation, which is the base for Ashtakar variable. So in case of intrinsic 3 metric, where CD belongs to curved bracket 1, 2, 3 on hyperspace sigma t induced and embedded in capital M. HCD is equal to GCD plus NCND, capital H of in squared bracket pi phi is equal to integration d raised to 4x pi phi dot minus L of in squared bracket phi dot bracket close. So equation becomes H of pi mu nu H mu nu is equal to integration d cube x pi cd HCD dot minus L of HCD dot. Here KCD is extrinsic metric is equal to HEC HFT del E and F is equal to DC and D. In this diagram, I have shown how intrinsic and extrinsic curvature is generated. First, flat geometry shows intrinsic metric while second shows extrinsic curvature. So we will have equation of Riemannian tensor, that is R alpha beta gamma eta is equal to H alpha sigma H mu beta H nu sigma gamma H rho eta R sigma subscript mu nu rho minus k beta eta k alpha gamma minus k beta gamma k alpha subscript eta. Here one can write four-dimensional Ricci curvature for scalar R using three-dimensional Ricci scalar. That is R raised to 3 for hypersurface sigma, and the extrinsic curvature of sigma as R is equal to R raised to 3 plus KCD k subscript cd minus k square, k is equal to kcd hcd. So here I have explained shortly the concept of intrinsic and extrinsic curvature. Let us see how one can derive Hamiltonian action in metric formulation. SEH, it means Einstein-Hilbert action is equal to integration d raised to 4x square root of minus g capital R is equal to integration dt d raised to 3x n square root of h in bracket r raised to 3 plus k superscript cd k subscript cd minus k square bracket close. Here hcd dot is equal to L subscript t vector hcd. So hcd dot becomes 2n kcd plus L subscript n vector hcd. To understand the derivation of this equation, I strongly recommend that please refer my research article. Due to the limitation of time, I couldn't explain each and every equation. Here, pi cd is equal to del L over del hcd dot is equal to square root of h in bracket kcd minus k hcd. H of pi cd hcd is equal to integration d cube x pi cd hcd dot minus L of hcd hcd dot. By some mathematics, final equation becomes h of pi cd hcd is equal to integration d cube of x capital N of minus square root of h raised to 3 capital R plus 1 over square root of h in bracket pi cd minus 1 half pi square bracket close minus 2 capital NC capital D pi cd. Here first term capital H is equal to in bracket minus square root of h raised to 3 capital R plus 1 over square root of h in bracket pi cd pi subscript cd minus 1 half pi square shows Hamiltonian constraint of metric formulation, while second term is cc is equal to capital C raised to c is equal to 2 capital D subscript D pi superscript cd is another kind of constraint. So final equation becomes h is h of pi cd hcd is equal to integration d cube x n h minus capital NC c raised to c. By defining classical quantities as operator, we can understand its transition. For instance, HCD tends to operator HC subscript CD. Pi CD tends to IH cut del over del H subscript CD. And Hamiltonian constraint and diffeomorphism constraint CC tends to operator H and operator CC. Let us understand the concept of triad and tetrad formalism. Metric tensor G mu nu is equal to e raised to j mu e raised to k nu eta jk. It is a kind of transformation. If you are aware about mathematics of general theory of relativity, you can easily understand this concept. Determinant of metric tensor G mu nu is equal to determinant of eta jk, determinant of e raised to j mu raised to square. So determinant of G mu nu is equal to minus determinant of ej mu of raised to 2. So e is equal to square root of minus g, where e shows triad or tetrad. Let us see what is spin connection. Similar to Christoffel symbol in general theory of relativity, we have defined gauge derivative and spin connection in quantum field theory. So here I have compared equation of general relativity with quantum field theory. For instance, gamma superscript eta subscript beta gamma is equal to 1 half g raised to eta sigma in bracket del beta g del gamma plus del gamma g delta beta minus delta g beta gamma bracket close. Similar to Christopher's symbol or affine connection, the equation of spin connection is omega raised to jk beta is equal to 1 half e raised to delta in squared bracket capital J in bracket del subscript squared bracket beta e raised to superscript capital K subscript delta squared bracket close plus small e raised to mod gamma capital K squared bracket close into small e raised to capital L subscript beta del gamma e subscript delta L bracket close. By this comparison and considering triad formalism and metric formulation, we will have equation of Palatini action, which is important to understand a Stoker variable, that is Sp of E omega is equal to 1 over 4k integration d raised to 4x tau raised to mu nu gamma delta tau subscript capital J K L M e raised to j mu e raised to k nu capital F L M subscript delta gamma. To understand this kind of mathematics, you have to consider Einstein's summation convention and mathematics of tensor analysis and mathematics of general theory of relativity. At first glance, it seems bitter and weird. Here, capital F superscript Lm subscript gamma delta is equal to del subscript squared bracket gamma omega subscript delta squared bracket close raised to capital Lm plus 1 half squared bracket omega Ln gamma omega subscript delta n raised to m squared bracket close. Let us see defined constraint in Palatini approach. Earlier we have defined two constraints, that is Hamiltonian constraint and diffeomorphism constraint. Here for any metric a j k, the tetrad is transformed as e raised to j c a raised to j k to e raised to k c by taking local special orthogonal 3 rotation. Here 3 metric HCD remains invariant. Thus, 3 new degrees of freedom is introduced in Palatini formalism, which are removed through extrinsic curvature 1 form, that is capital K superscript J subscript C is equal to KCD raised to J D. By defining new constraint, that is Gauss constraint, that is capital G CD, KCD is symmetric, and the equation will be GCD is equal to capital K raised to J subscript in squared bracket C small e raised to K subscript D squared bracket close delta JK is equal to 0. The phase space variable 3 metric and 3 momentum are replaced by ADM variable HCD and pi CD if Gauss constraint is followed. Here all 3 ADM constraints can be written as follows. So equation 45 is source Gauss constraint, Equation 45b shows diffeomorphism constraint and equation 45c shows Hamiltonian constraint. Let me explain what is Ashtakar's variable. In 1986, Abhay Ashtakar introduced new kind of variable in classical and quantum gravity. In this formulation, the constraints are simplified by embracing a complex valued form for the connection and tetrad variable. These are nothing but Ashtakar variables. As usual, a 3 plus 1 decomposition is performed in the next step to get the Einstein-Hilbert Ashtakar Hamiltonian, that is H subscript EHA, sum of all constraints. Here, first order formulation by Palatini action is incomplete, but Ashtakar's complex values version of this formulation makes it complete. And in Palatini formulation, Hamiltonian constraint is a complicated non-polynomial function. Thus, canonical quantization is difficult within this formalism. So, by transforming tetrad formalism into triad, three-dimensional hypersurface sigma t, the tetrad at each point are converted into triads, that is, e raised to j mu tends to e raised to j c, where mu tends to c belongs to in curved bracket 1, 2, 3, and capital J tends to small j belongs to in curved bracket 1, 2, 3, and the spin connection is also likewise converted as gamma raised to jc is equal to omega ckl epsilon superscript kl j. In Ashtakar's formalism, the real connection omega raised to jk subscript mu is replaced by complex valued connection gamma raised to jc with duality, which may be either self, that is plus 1, or anti-self, which is denoted as minus 1. So the Ashtakar's variables are tilde capital E raised to C subscript j tends to 1 over I, tilde capital E raised to C subscript j, comma capital K raised to j subscript C tends to capital A raised to j subscript C is equal to gamma j c minus I capital K j c. Here A raised to j subscript c is the Ashtakar-Barbero connection or special connection, while capital K raised to jc is equal to kcd e raised to dj, with kcd is the extrinsic curvature of sigma and tilde capital E raised to cj is the scalar density or triad electric field. Using these variables, the constraints are simplified. That is, we will have three equations of constraint, that is Gauss constraint, diffeomorphism constraint, and Hamiltonian constraint, which I have shown in equation 47, 48, and 49. So the resulting equation of Einstein-Hilbert-Ashtakar-Hamiltonian of general relativity is capital H subscript EHA is equal to NC C subscript C plus capital NH is equal plus capital T raised to J, capital G subscript J is equal to 0. And since here time dimension is not considered, another equation is capital H subscript EHA ket vector psi is equal to 0, which is also known as Wheeler-DeWitt equation. Here, appearance of unit imaginary, that is I is equal to square root minus 1 in the equation makes the theory complex valued. So, to get tangible physical results relevant to a metric valued in real number instead of in C, some restrictions on the possible solution of theory must be imposed. For instance, the notation y dot is used to represent time derivative of y, then the constraint and reality condition must be satisfied by solution. So tilde capital E raised to C subscript j tilde capital E raised to D subscript k delta jk belongs to R, and in bracket tilde E raised to C subscript j tilde E raised to D subscript k delta jk dot belongs to R. So in general, Astakar's variable can be written as tilde capital E raised to C subscript j tends to 1 over gamma tilde E raised to C subscript j, and second is capital K raised to j subscript C tends to capital A raised to j subscript C is equal to gamma j C minus gamma capital K raised to j C. Here gamma is known as Barbero-Immersi parameter or an arbitrary complex number. So using this whole equation, one can have equation of Poisson's bracket or equation in terms of quantum mechanics, that is in curved bracket a raised to j subscript c of x, comma tilde e raised to d subscript k of y is equal to 8 pi g gamma delta raised to c subscript d delta raised to j subscript k delta cube in bracket x minus y. So with real number value of gamma, the form of the equation of Hamiltonian constraint again becomes complicated with another term quadratic in both the triad and extrinsic curvature. That is defined by equation 56. By considering gamma is equal to I, the second term in the above equation is disappeared and equation 56 becomes simple. So this is the importance of immersive parameter and Astakar's variable. So as I mentioned earlier, Wilson loops are responsible in loop quantum gravity to create loop states. That is why it is the origin behind the name loop gravity. So let us consider a solution with a state psi of A, that is sum of all loops or Wilson loops. Psi of A is equal to sigma lambda psi of lambda capital W subscript lambda of capital A. As the intersection of these loops are allowed and gives quantum spacetime in loop quantum gravity, these loops are noted also and offers different topology from each other. Earlier in my channel, I explained that in loop quantum gravity, field lines are allowed to intersect, puncture, and pierce, and by this way it will create nodes, waves, and loop state. The state psi of A follows the diffeomorphism constraint. In fact, diffeomorphism invariance actually helps us reduce the number of basic states. That is Gauss constraint. It means the state has background independence and Wilson loops are gauge invariant. Because of background independence presence in loop quantum gravity, deformation of loop states can be avoided, and any two loops that are smoothly deformed into each other. Thus, the space of loops exhibit of only single member of each topological relevant class. In case of absence of diffeomorphism invariance, the theory will be background dependent, and hence any modification in the shape of Wilson loop gives various holonomy due to path-dependent parallel transport, which leads to deformed loop state to other loops. So in the canonical quantization, canonical variable are promoted to operator. So here one can replace Poisson bracket by commutator relations. So operator tilde e raised to c j psi of a is equal to minus I del psi of a over del a j c. Since capital E superscript c subscript j tends to minus I h cut del over del a j c. Here classical operator triad is replaced by quantum operator. So in squared bracket, operator a k d of y, comma, operator tilde e raised to c subscript j of x, squared bracket close is equal to I del cd del kj del cube of x minus y. Earlier, I have explained what is spin network in loop quantum gravity and why it is useful to generate loop states in loop quantum gravity. Here I will again explain what is spin network in short. So by considering a loop state as a graph or network theta with edges ei labeled by elements of some gauge group, which may be generally SU2 or SL2C. So psi theta is equal to psi of G1, G2 up to Gn, where Gj are group elements and J is equal to 1 to 3 up to and is the holonomy in bracket group element of connection A along jth edge. Here one can demonstrate this loop state as states of quantum geometry in which label of edges are group element that denotes the holonomy at each edge. So as I explained earlier, in loop quantum gravity, field lines are allowed to intersect, puncture and pierce, and these puncturing piercing will give us waves and knots of loops, and in turn which will give us spin form in covariant approach. So historically, this representation was firstly given by Nobel laureate physicist Sir Roger Penrose. He named it a spin network in which combinatorial principle of angular momentum was used, and it proved to be crucial in canonical quantization of quantum gravity theory. Another thing is in spin network, edge are labeled by group elements, that is G1, G2, G3 up to Gn, and in case of LQG, 3 group element is group representation, that is angular momentum J. In these two diagram I have shown spin network. First diagram I have shown group elements. In the second diagram I have shown group elements in terms of angular momentum. So LQG is the quantum theory of geometry in which geometrical observables such as area and volume can be quantized. Let's see how it is possible. In classical geometry, the area of two-dimensional surface capital S, which is embedded in manifold sigma, is written as a S is equal to integration d square x square root of q raised to 2, where q raised to 2 is the determinant of metric QCD. The area is two-dimensional, as we all know, hence the component of two-dimensional metric QCD can be denoted as the yard basis in curved bracket e raised to jc. Here jk are internal indices and cd belongs to curved bracket xy are spatial indices. Here two-dimensional metric QCD and its metric element are written in equation number 62 and 63. So determinant of its metric becomes determinant of QCD raised to 2 is equal to Q11 Q22 minus Q12 Q21. So which in turn will become vector Ez dot vector Vz. As I mentioned earlier, in spin network, priori the direction is unknown. So total angular momentum is more important than angular momentum. And that is why the equation 64 is obtained by simple mathematical operations. Hence, the classical geometry can be written as AS is equal to integration d square x square root of vector Ez dot vector Ez is equal to integration d square x square root of delta jk delta over delta azj into delta over delta azk. Hereby avoiding possibility that edges are tangent to surface S and vertex is created by intersection of loops. One can generate area through intersection of these loops. So by this mechanism in loop quantum gravity, various geometrical observables are quantized and by this way, loop quantum gravity quantized space. So in the LQG formulation, the field lines are allowed to intersect, pierce, and puncture, and by this way it will create knot, and the edges of graph theta intersect the surface S at many end locations and point of intersections, which are in curved bracket P1, P2 up to Pn. So only in the neighborhood of the punctures, the state psi theta will have non-zero area. So operator AS psi theta is equal to summation P is equal to P1 to Pn in square root delta Jk delta over delta Az J of P into delta over delta Az K of P psi theta. Here from equation one can say that area operator is applicable to only holonomy GL at Lth puncture and the connection A is solely dependent on position P. Therefore, the functional derivative of the holonomy with respect to the connection can be written as delta over delta ACJ to delta over delta ADK psi is equal to NC ND JJ JK psi. Operator AS psi theta is equal to summation F square root in square root delta JK NC ND JJ JK psi theta. So operator AS psi theta is equal to summation F square root of J square psi theta. Here N superscript C into N subscript C is equal to 1. In the previous slide, this diagram shows puncturing through surface, and by this puncturing the given surface gets area. Here in the equation 69, J square is Casimir operator of the rotational symmetry SO3. It is the element of algebra summation C, capital X subscript C, X superscript C, where X, C are the bases of the relevant Lie algebra and X superscript C are the dual bases with respect to some invariant mapping of the bases and dual bases to the scalars. Here, vector capital J subscript J is the jth component of angular momentum operator that operates on the spin labeled to a given edge. All elements of the Lie algebra are commuted with the Casimir operators. Here on spin state, the action of J square is written as capital J square cat vector small j is equal to j in bracket j plus 1 cat vector j. So equation of area operator becomes operator as psi theta is equal to lp square summation k square in square root jk in bracket jk plus 1 psi theta. By assigning the angular momentum label jk to each edge of theta and inserting Planck area lp square in the equation, the final equation of area operator is Operator AS psi theta is equal to 8 pi gamma LP square summation k in square root jk in bracket jk plus 1 psi theta. Here gamma is emerging parameter. Similar to area operator, area observable, area volume observable is also quantized and known as quantum volume operator. In classical geometry, this area resided on the boundary of volumes. So volume operator can be found which is analogous to area operator. As shown, volume of a region of space S can be obtained in 2D case. So capital V is equal to integration d cube x square root h is equal to 1 by 6 integration d cube x in square root epsilon bcd epsilon jkl ebj eck edl. Hereby promoting geometrical observable volume to volume operator, the equation of volume operator is obtained, which is operator V is equal to 1 by 6 integration d cube x in square root epsilon bcd epsilon jkl del over del a jb del over del akc del over del ald. Here NC into del over del AJC psi gamma is equal to operator JJ psi gamma. So equation 75 becomes operator V psi theta is equal to 1 by 6 integration d cube x in square root epsilon BCD epsilon JKL NB NC ND operator JJ JK JL psi theta. In loop quantum gravity, solution of Wheeler-DeWitt equation is found at points of intersection, that is vertices. So the action of volume operator is non-zero at these vertices of the graph theta. So in the end, the integral of the volume operator reduces to a sum over a finite number of vertices V belongs to theta that resides in S intersection theta. So operator V psi theta is equal to 1 by 6. V belongs to S intersection theta summation in square root epsilon BCD epsilon JKL NB NC ND JJJ KJL sine theta. So earlier I have explained this portion while explaining new quantum spin perspective. So I will skip some of the equation. I explained that on the basis of orientation of edges that come in or emerge out at the vertex, there are two type of equations of volume operator, Rovelli-Smolin and Astaker-Lewandowski type that I have given in equation 79 and 80. In 79 and 80, gamma is emerging parameter, LP cube is Planck volume, epsilon BCD is alternating tensor, and epsilon V in bracket NB and CND belongs to curved bracket -1, 0, 1 is the orientation of three tangent vector at vertices V to the three edges that meet together at V. I have explained the mathematics of these two equations in my that lecture, so viewers can find this explanation in that lecture. So the concept of spin network, firstly proposed by Penrose in terms of combinatorial principle. Spin network is a kind of graph in which edges are labeled by some representation group, that is edge group SU2 or SL2C in LQG. The spin network gives quantized cross-sectional area and volume through the links of this network and the vertices of this network respectively in loop quantum gravity. These links and vertices determines the values of area and volume by the spin notation on the corresponding links. To make sure that angular momentum is conserved at vertices, an intertwiner is assigned to each and every vortex. Each link communicates with parallel transport of spin from one vortex to another. In case of trivalent vortex that I have given in this figure of atom of space, force spin is given as J1, J2, J3. Each edge punctures one face of the trihedron. On basis of earlier equation, the value of area is obtained through such sort of puncture. Also, its eigenvalue also determined. So similar to matter has smallest constituent, and that is atom. Radiation has smallest constituent, that is photon. Quantized space has smallest constitution, that is atom of space. This till this moment I have explained canonical approach of loop quantum gravity. Now I will explain covariant formulation of loop quantum gravity. Spin form uses Lagrangian formulation to quantize gravity, similar to Schrödinger and Heisenberg formulation that are governed by states and operators. Respectively, the Feynman's path integral approach are governed by transition probabilities between two states. Here, spin form uses Feynman's approach as sum over geometry to find the transition amplitude of quantum geometry. In relativity, the path integral means the transition between geometries. So, LQG, as LQG originated from general relativity, Feynman's sum over history has some meaning in LQG. In LQG, the Lagrangian approach or sum over geometry gives transition amplitude between geometry in which each path between the initial and final states are weighed by an exponential function of the action related to that path. Suppose the initial and final states of hypersurfaces are get vector HCD, T and H prime CD, T prime respectively, with HCD is the intrinsic metric of a considered hypersurface of space and C, D belongs to 1 to 3. Then during the evolution of geometry, the probability of transition from initial to final state can be written as J vector HCDT into ket vector H prime CDT is equal to integration capital D of G mu nu exponential in bracket I S subscript EH of G mu nu, where D of G mu nu is the proper measure on the space of four matrix. By interpolating between initial and final hypersurfaces, the action is accessed over all four matrix G mu nu. This approach is known as covariant loop quantum gravity or spin form formulation of loop quantum gravity. So in this diagram, I have shown evolution of spin network, which gives spin form. Spin network provides kinematical picture of quantum geometry, while spin form gives dynamics of quantum geometry. Here, evolution of spin network with its history is known as spin form theory that provides covariant formulation of low quantum gravity. A slice of a spin form gives spin network state. Based on Lagrangian action with Feynman sum over history approach, spin form formulation can calculate the transition amplitude between two states of quantum geometry by taking sum over all possible states between initial Si and final Sf. So the boundary configuration of spins gives transition amplitude of quantum geometry. Here, by considering splitting and joining the edges and vertices of spin network states of kinematical Hilbert space, the states can be evolved from one to another states that gives rise to spin form. For instance, conversion of single vertex to two vertices, that is 1 to 2, and inverse is also possible. So in this diagram, I have shown splitting of one node to two nodes. Let us see application of loop quantum gravity. First application is found in black hole thermodynamics or in black hole physics. So first of all, let us see what is black hole in short. A black hole, one of the solution of Einstein's field equation, is a space-time region where gravity is so strong that even light cannot escape. When any massive star runs out of fuel and ends its life, it collapses. At last, it is converted into black hole. In general, in general relativity, black hole is completely characterized by just three parameters, that is mass, charge, and angular momentum. Earlier, I have explained Schwarzschild solution or metric of Einstein's field equation. So, according to this solution, black hole is generated. In this solution, Schwarzschild metric is given as, I have given that metric in equation 82. One can find its description in my YouTube channel, where r is equal to square root of x square plus y square plus z square. Volume element d omega square is equal to d theta square plus psi square theta d phi square. R is equal to 2m. Coordinate singularity is occurred. That is the event horizon of black hole, and at r is equal to 0, curvature singularity is occurred. Let us see some basics of black hole entropy. The upper limit of black hole's entropy or maximum number of degrees of freedom, that is Bekenstein bound, relies on black hole's area. Because volume dependent Bekenstein bound violates second law of thermodynamics. So entropy of black hole must be proportional to its area of event horizon. In 1971, Bekenstein discovered that black hole's entropy is proportional to its area, but not its volume. As area of event horizon of black hole always increases, that is delta A greater than or equal to 0, and it is analogous to second law of thermodynamics. That is, entropy either increases or remains constant, that is, delta is greater than or equal to 0. In other way, the equation of entropy equation is given by S is equal to alpha A, where alpha is universal constant. Thereafter, Hawking came up with another idea that black hole is not completely black, rather it emits radiation, which is known as Hawking radiation. It has temperature, that is Th is equal to h cut c cube over k 8 pi g m. Here temperature of black hole is proportional to its mass, that is Th proportional to 1 over mdh. On the basis of Bekenstein's conjecture, Hawking derived the equation of entropy of black hole, that is Bekenstein-Hawking entropy formula. SPH is equal to k beta A over 4 Lp square is equal to k beta C cube over 4 GH cut A is equal to alpha A. Here k beta C cube over 4 GH cut is constant. LP is Planck length, that is square root of GH cut over C cube. K beta is Boltzmann constant. G is universal constant. H cut is reduced Planck constant. And A is the area of event horizon. So in physics, there are several meanings of entropy, such as entropy is the measure of disorder or randomness. It is a measure of incomplete information or lack of information, or it means maximum number of microstate corresponding to macrostate. That is S is equal to K beta ln omega. It is equation of Boltzmann entropy or loss of energy to do work. Let us see how LQG derived black hole entropy formula. In LQG, some concepts are used to describe this concept, that is statistical mechanics, probability theory, combinatorial principle, quantum information theory, etc. Here, any surface acquires area when linked pairs or punctures that surface. one can assign microstates to each piercing and puncturing to surface. So this is how surface area is generated in loop quantum gravity, and this is how one can get the idea of black hole entropy in loop quantum gravity. So the microstates are related to the discrete pieces of the surface that gives the value of area spectrum by piercing. So entropy S is proportional to the log of the number of ways in which the sphere can be pierced or punctured, which gives an area within each macroscopic interval. So in this diagram, I have shown puncturing or piercing, and puncturing of boundary of event horizon of black hole by lines of spin network gives the value of quantized area. The eigenvalue of the area operator with the jk of the form mk by 2, where mk belongs to z, can be written as a is equal to 8 pi gamma lp square summation k is equal to 1 to n in square root mk by 2 in bracket mk by 2 plus 1. To know more regarding the derivation of black hole entropy, please refer my research article and references of my research article. So k is equal to 4 pi gamma lp square in square root mk in bracket mk plus 2. The final equation is k is equal to 4 pi gamma lp square in square root mk plus 1 square minus 1. Here, in an interval that is a plus delta a, comma a minus delta a. Delta A is some small interval, that is delta a by a, very less than 1. A is macroscopic value of area and the permitted number n of m of sequences of integer, that is mk up to mn. K is equal to 1 to 3 up to capital N is determined by the number of edges that puncture the surface in such a way that the determined value for the total area lies within the considered interval. Here capital M is equal to A over 4 pi gamma LP square. M is equal to summation square root of mk in bracket mk plus 2 belongs to the square bracket a plus delta a comma a minus delta a. Next approach is Rovelli's approach, that is given by Carlo Rovelli, one of the founder of loop quantum gravity. Here, by considering given set of inequality, that is summation k in square root mk square less than summation k in square root mk in bracket mk plus 2 is equal to summation k in square root in bracket mk plus 1 square minus 1 less than summation k in square root mk plus 1 square. N minus of m is less than n of m, which is less than n plus of m. I have given more equation in my research paper, and to know more regarding this approach, please refer references that is given in my research article. So ln n plus of m is equal to in bracket ln 2 m. So ln n of m is equal to dm, and ln n minus of m is equal to ln 1 plus square root 5 by 2. Next equation is ln 1 plus 5, 1 plus square root of 5 by 2 less than d less than ln 2. That is, it means 0.48 less than d less than 0.69. So capital M is equal to a over 8 pi h cut g. Ln n of m is equal to dm, and ln n of a is equal to d a over 8 pi h cut g. Let us see what is the physical significance of it. According to Carlo Rovelli in statistical mechanics, entropy controls the thermal properties of the black hole in its interactions and with its surrounding is evaluated by the number of microstates of the quantum geometry of the black hole surface distinguishable from the exterior of the black hole. So S of A is equal to K ln N of A. C is equal to D over 8 pi is equal to 1 by 4. S of A is equal to C K over H cut G A. So this is how entropy formula for black hole is derived in Rovelli's approach in loop quantum gravity. Next approach is number theoretical approach. In this approach, by solving Pell's equation through determining allowed sequences, the number theoretical approach is obtained with the unites 4 pi gamma LP square is equal to 1. So the total area for the specified set of n punctures on a quantum horizon is A is equal to summation k is equal to 1 to n, a k is equal to summation k is equal to 1 to n in square root mk plus 1 square minus 1. Here m belongs to z, tends to m plus 1 square minus 1 belongs to z. So it can be written as square root m plus 1 square minus 1 is equal to ym square root of pm. It means that the area eigenvalue can be expressed as an integer linear combination of square roots of square free number. That is, capital A is equal to summation k is equal to 1 to k max yk square root of pk. So m in square root mk plus 1 square minus 1 is equal to yk square root of pk. If xk is equal to mk plus 1 assigned, that is xk square minus pk yk square is equal to 1. So that is the final equation that is known as Pell's equation. Next application is loop quantum cosmology. In loop quantum cosmology, we study Big Bang model. We also study standard model of cosmology with different perspective by eliminating singularity and with many other features. So loop quantum cosmology is very important branch and application of loop quantum gravity. It replaces Big Bang singularity through the Big Bang's model in which singularity is disappeared. This is the basic and attractive feature of loop quantum cosmology. Since LQG originated from general relativity, it studies cosmology with quantized space-time geometry with isotropic and homogeneous metric. Isotropy necessarily suggests homogeneity, but the opposite is not relevant. In symmetry-reduced model, one can understand this sentence. Here, the study of LQC can be done with the metric variable, connection variable, and holonomy variable that I have given in my research article. Those who want to know in more depth can refer my research article. So basic or salient feature of loop quantum cosmology is removal of singularity through Big Bang's model. It explains cycle of contraction, expansion, and by this mechanism one can remove singularity from Big Bang model. How? Let us see. The action of the volume operator V in LQG can be written as operator V psi theta approximately equal to summation V belongs to S intersection theta and square root epsilon DCD epsilon JKL NB NC ND JJ JK JL. Here operator J has minimum eigenvalue of 1/2 and the volume operator V has the smallest possible volume eigenvalue is of the order of gamma raised to 3 by 2 LP cube. So volume operator V ket vector mu is equal to in mode operator P raised to 3 by 2 ket vector mu is equal to in bracket and pi gamma LP square over 3 raised to 3 by 2 mu raised to 3 by 2 ket vector mu. The states psi mu of C is equal to ket vector mu are the triad operator eigenstate. Here how This model removes singularity. Let us the factor of operator p raised to minus 3 pi do in the LQC Hamiltonian stays bounded throughout the evolution of the universe. In general relativity, as the initial Big Bang singularity is reached, the scale factor diverges A tends to 0, yielding to infinite energy densities for the scalar field. Since P approximately equal to A square, but in loop quantum cosmology, operator P raised to minus 3 by 2 has an upper limit of the order of LP cube, guarantees that such divergences don't occur in loop quantum cosmology. So this is how Big Bounce model removes singularity from Big Bang model. So here I have shown various conclusions of my research article. This is the published research article. One can find in search engine, one can also find in the Gravitation Cosmology journal. Thanks for listening and watching. If you have any question regarding loop quantum gravity, its applications, its basic, its framework, you can ask in the comment section. If you like my video, please share and subscribe my YouTube channel.